Hey everyone, in this series we're exploring the Web LLM Attack labs from PortSwigger. These challenges are like real-world scenarios where large language models are integrated into web apps. And our goal is to see how they can be exploited safely in a lab environment. Before we jump into solving the PortSwigger LLM challenges, it's important to give you a quick overview of LLMs and how attacks against them work. These models are super powerful. They can generate text, chat with users, and even access internal APIs. But the same power, if not protected, opens up brand new attack surfaces. To explain this better, I like to use the decision tree analogy. At the root, the model takes in context. Things like user prompts, page content, or product reviews. From there, the tree splits into two main branches. The first one is output-based, where attackers try to manipulate the model's output to leak sensitive information or trigger dangerous actions. The second is input-based, where attackers inject malicious content into inputs. From an attacker's perspective, the goal is to push the model outside its safe boundaries. Things are revealing secrets, calling internal APIs, or performing unintended actions. Techniques include prompt injection, indirect prompt attacks hidden in user content, and abusing excessive model permissions. In short, every time the model decides what to output or which function to call, an attacker is trying to hijack that decision. In this video, we'll walk through some lab examples together, see how these attacks work, and most importantly, learn how to defend against them. Okay guys, let's jump in and solve our very first lab. Lab 1. Exploiting LLM APIs with excessive agency. In this challenge, the LLM has too much power and can execute command directly on the database. Here's what we did. First, we asked the LLM what APIs it can access. We found a debug SQL API that can run any SQL command. Then, we checked the API's input. It accepts a full SQL statement. That means it can read, modify, or delete data. Next, we ran the test query to see which users exist and found a user called Carlos. Finally, we instructed the LLM to delete the user and the lab was solved. Short summary. This challenge shows that giving an LLM direct access to database without restrictions can be really dangerous. Even a simple command can cause serious changes. Always make sure access is limited and safe. Lab 2. LLM RC via newsletter subscription API. In this lab, the LLM can access several APIs, like password reset, newsletter subscription, and product information. Since we don't have any account, testing the password reset API is tricky, so we focus on the newsletter subscription API instead. We ask the LLM what arguments the newsletter subscription API takes. Then, we test it by subscription and email with control proving the LLM can interact with the API directly. Next, we use a command injection trick with who am I in the email address. The resulting image showed that the command executed successfully, confirming remote code execution is possible. Finally, we sent a command to delete Carlos' file. The file was removed and the lab was solved. Short summary. This lab shows how dangerous it is when an LLM is given access to APIs without proper validation. Even something as simple as a newsletter subscription endpoint can be abused for remote code execution.